Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 3 of areas related to circles. Okay my dear friends, I hope you will enjoy this lecture. So my dear friends, without wasting the time, let's start. Okay, so my dear friends, today we are going to discuss segment of a circle. Segment of a circle. So, this segment we already learnt in the previous lectures. Okay, so my dear friends, in this lecture we are going to discuss in detail. Okay, so yes, my dear friends, what is segment? Okay, so a segment is a part of circle. A segment is a part of circle, basically the region between the chord and an arc. The chord and an arc. Let's suppose this is a chord AB and we have an arc ACB. So this is the segment, but the segment is this minor segment. This segment is what? Yeah, this is minor segment. And what is my major segment? So the major segment is the area between the chord and the major arc. Major arc we have ADB and minor arc we have ACB. Okay my dear friends, I hope you understand these things. Okay, so my dear friends, I hope you understand these things. The segment is the interior part of the circle. The segment is what? It is the interior part of the circle. So now let's move on. Yes, now let's come on the area of segment of a circle. Okay, yes. So my dear friends, the formula to find segment area can be either in terms of radians or in terms of degree. Okay, so the area can be in terms of radians or in terms of degree. Okay my dear friend, so let's suppose this is a circle. This is what? Yes, this is a circle and we have a segment like this. We have a segment like this. This is a segment. Now the area of the segment is half into r square into theta minus sine theta. This is the area of segment, but this area is in radian. Okay my dear friend, so this is area of segment. This is what? Area of segment in radians. Okay, so now what is the area of segment in degree? So area is equals to half into r square into pi upon 180 into theta minus sine theta. So this is what? Yes, this is the area of segment in degree. Okay, so this is the area of segment in degree. Segment in degree. So now my dear friends, these are the formula of segment of a circle. What? Yes, segment of a circle. So now my dear friends, let us see how to calculate the area of segment of circle. How to calculate the area of segment of circle. Okay, so my dear friends, before this, first of all, we have to know how to convert degree into radian or radian into degree. So this is a formula that, okay, radian is equals to pi upon 180 degree into degree. Now let's suppose we have an angle in degree, then we can convert into radian by this formula. Okay, and if we have an angle in radian, then we convert it into degree. How? We can convert it into like this. Degree is equals to radian into 180 divided by pi. So these are the formulas to convert into each other. You can convert from degree to radian, or you can convert from radian to degree. Okay, yeah. So now let's come to the main topic, how to calculate the area of segment of circle. Okay, so my dear friends, we have a circle, and we have a sector O, A, O, B, and we have a segment AB like this through this arc. Okay, now we have to find the area of this red part, Okay, my dear friends, how we can calculate it? Let's see that. So my dear friends, in this figure there is a theta, angle theta. Okay, and this theta is in degree. Angle AOB is what? It is theta, which is in degree. Okay, my dear friends, now we know that area of sector okay, let's suppose this point is C. Okay, so area of sector OACB, is what? We know the formula. Area of sector OACB is equals to theta upon 360 degree into pi r square. We have radius r. Okay, now my dear friends, area of segment is what? Area of segment ACBA. This segment area ACBA. Okay, so this is what? This is the area of sector minus area of this triangle. Okay, so we can find the area of segment by subtracting the area of triangle from the area of sector. So that's the method to find the area of segment. Okay, my dear friends, so let's find that. Yes, so my dear friends, area of segment ACPA is equals to area of sector OACB minus area of triangle AOB. Okay, my dear friends, so from this formula we can find the area of segment. Now my dear friends, we know this area of sector OACB, but now we have to find the area of triangle AOB. Okay, so now my dear friend, let's find the area of triangle OAB. So now my dear friend, for finding the area of triangle OAB, let's suppose we have a triangle like this. This is triangle OAB. Now my dear friends, this is radius r and this is also radius r. Now we have to draw a perpendicular on AB at point P. So this is what? Perpendicular line. Okay, my dear friends. So now my dear friends, this perpendicular line is divided AB in two equal parts. Okay, now this line is also divided the angle theta in theta upon 2, theta by 2. Okay, so now my dear friends, in right triangle, this is a right triangle AOP. Okay, AOP is what? It is a right triangle and right angle is at P, at point P. So my dear friends, we know that in this case, hypotenuse we have radius, base we have OP. OP is what? This is a base, and perpendicular we have AP. Now with the help of these, we know that cos theta is equals to what? Base upon hypotenuse. We know very well. And in this case, theta we have theta by 2. So we can write cos theta upon 2. And we have base is what? OP. And hypotenuse we have R. So this will become, we have OP is equals to R cos theta upon 2. OP is what? R cos theta upon 2. Okay. And now my dear friends, area of triangle OAB is equals to, we know that half into base into height. And what is base? Our base is AB. And what is height? Our height is OP. Okay, my dear friends. So now, my dear friends, we have OP. But now we have to find AB. How we can find it? Let's see that. So now, my dear friends, we know that AB is equals to twice of AP. Okay. Now, my dear friends, for finding the value of AP, we can find in right triangle OAP. So in this, we can find the AP because AP is what? Perpendicular. And we know that sine theta upon 2 is what? Perpendicular upon hypotenuse. Okay. And what is perpendicular? Perpendicular is AP. And what is hypotenuse? Hypotenuse is radial. So we have AP is equals to R sine theta by 2. R sine theta by 2. Now we put the values in this equation. So we get AB is equals to 2R sine theta upon 2. Now we are putting the value of AB in the area of triangle. So the area of triangle will become area of triangle AOP is equals to half into base, which is 2R sine theta upon 2, multiply height. What is height? So the height is R cos theta upon 2. Now from this, these two will be cancelled. Okay, so we get R square sine theta upon 2 and cos theta upon 2. So this is the area of triangle AOB. If we know the value of theta and R, we can easily find the triangle AOB. Okay, my dear friends. So my dear friends, we have to put these values in this equation. So we know the area of sector is theta upon 360 into pi r square minus area of triangle AOB is what? It is R square sine theta upon 2. Okay. Sine theta upon 2 into cos theta upon 2. So this is the formula of area of segment ACBA. So my dear friends, I hope you understand these things. You understand these things. So this is the formula. If you know the formula of, if you know the area of sector and area of triangle, then you can easily find the area of segment. So this is the area of minor segment. Area of minor segment. Okay, my dear friend. And if we want to area of major segment, which is what? So area of major segment is equals to area of major segment is equals to what? Area of circle minus area of minor segment. Area of minor segment. So this is the area of major segment. I hope, my dear friends, you understand these things. Okay. So my dear friends, I hope you understand these things, how to find the area of segments. Okay. So now, my dear friends, let's move on. Yes. Theorem on segment of a circle. Okay, so now my dear friends, there are some theorems based on the segment of a circle. Okay my dear friends, so now my dear friends, the theorems are, let's suppose first theorem is we have alternate angle theorem. Okay, second theorem is alternate segment theorem. Okay, and this is also called inscribed angle theorem. Okay, third theorem is angle in the same segment theorem. So these three theorems we are going to discuss. Okay, so my dear friends, first theorem is alternate angle theorem. This theorem states that in any circle, the angle between a chord and a tangent, in any circle, the angle between a chord and a tangent. Let's suppose we have a chord AC and there is a tangent DC. Okay, so the angle between the chord and a tangent through one point of the ends of the chord is equal to the angle in the alternate segment. Is equal to the what? Angle in the alternate segment, means is equal to this angle ABC. So according to this statement, we can say that angle ACD is equals to angle ABC. Let's suppose we are taking angle ACD is X, which is equals to angle ABC. So this is the statement of this theorem. I hope my dear friends you understand these things. Okay. Yes, so now let's see the proof of this theorem. Okay, now you can see in the figure. Okay, let C be the point, let C be the point on the circumference of a circle, like here is, okay, on the circumference, of the circle. Got it? And here is O, be the center of the circle, be the center of the circle. Okay my dear friends, now assume that here is this CD, okay, this line, okay, is passing through point C, and which is a tangent. Okay, so now here is, we can say that DC what? DC is the tangent. DC is the tangent of the circle. Now the tangent makes an angle X. This tangent make an angle X with chord AC. Okay, so we have AC is a chord. AC is what? AC is the chord of the circle. Okay, and the chord and the tangent make an angle X. Okay, so here is the tangent makes an angle X, okay, with chord AC, okay. Yes, so now in triangle ABC, in this triangle ABC, okay, let's suppose, let angle ABC, we are assuming this is angle P. Okay, we are giving this, let's suppose angle ABC is what? This is angle P. Okay, and we have to prove angle X is equals to angle P. Okay, so this is the condition which we have to prove, means this angle is equals to this angle. Okay, yes, so this is very easy to prove this. Okay, now here you can see that we know that in this, you know that OA is equals to OC, because they are what? They are the radius of the circle. Okay, so we can write here as OA is equals to OC. Both are the radii of circle, and we know that these are what? These are equal. Now here you can observe this, these sides are equal. Okay, so we can say that these angles are equal. Angle OAC and angle OCA are equal because triangle OAC is what? Isosceles triangle, because these two sides are equal, and angle opposite to the equal sides are also equal. Okay, so we can write here as also angle OAC is equals to angle OCA. Okay, because we can write this reason that the angles opposite to the equal sides are equal sides are what? Are equal. Okay, I hope you get this point. Now we know that triangle OAC, this is what? This is isosceles triangle. So in triangle OAC, got it, we can write here as angle AOC is equals to 180 minus angle OAC minus angle OCA. We can write this because we know that the sum of all interior angles is what? The sum of all interior angles is equals to 180 degree. So here is, we can write like this. Okay, so now here is 180 degree minus, here is, you can see that angle OAC is equals to angle OCA. Okay, so here this will become like, we can write as angle, we can write angle OCA in place of angle OAC. Okay, minus angle OCA. So this will become 180 degree minus twice of angle OCA. Okay, this is what? This is twice of angle OCA. Now let's suppose angle OCA is Y. Okay, and if this is Y, then angle OAC is also equals to Y. Okay, so now here is, we can write as angle AOC is equals to 180 degree minus 2Y. Okay, let's suppose this is equation number 1. This is equation number 1. Got it? Now in this, we know that this angle is angle OCD. This is what? This is 90 degree. This is 90 degree. Okay, so here is angle OCD is 90 degree because this side OC is radius. Okay, and we know that radius is perpendicular to the tangent. So we can write here as the OC is perpendicular to DC. Okay, because the line segment DC is the tangent and OC is the radius. Okay, so here is angle OCD. This is equals to 90 degree. This is equals to 90 degree. Okay, so angle OCD is what? Angle OCD is Y plus X. So we can write here as Y plus X is equals to 90 degree. So from this we can find the value of Y. So this is 90 minus X. Okay, so let's suppose this is equation number 2. So put the value of y in equation number 1. We can find here is angle AOC is equals to, okay, we have 180 degree minus twice of y means 2 into 90 minus x, 2 into 90 minus x. If we open this bracket, we get 180 degree minus 180 degree. Here is minus minus plus, so this will become twice of x. Okay, so this 180 and this 180 will be cancelled, so we get 2x. Okay, so we have angle AOC is equals to twice of x. So I hope you get this point. So by the theorem, we can say that this angle, okay, this angle is twice this angle. Okay, so we can write here as angle AOC is equals to twice of angle ABC. Okay, we will see later in this lecture about this theorem. Okay, we also prove this theorem. So now you have to learn this angle AOC means this angle is twice this angle. Okay, so we have angle AOC is what? So angle AOC is twice of x. Okay, and here is 2 angle ABC is, we know that this is P. This angle 2 and this 2 will be cancelled, so we get x is equals to P. So from this we can say that angle ACD is equals to angle ABC. We can write here as and proof. I hope you understand these things, my dear friends. Okay, yes, now let's move on. Theorem number 2 is inscribed angle theorem. Inscribed angle theorem. So now what is this theorem? Let's see that. So this theorem states that an angle theta, okay, an angle theta inscribed in a circle is half of the central angle 2 theta that subtends the same arc on the circle. So now my dear friends, according to this statement, okay, according to this statement, we can say that in this circle and in this triangle, we can say that angle AOC is equals to twice of angle ABC is equals to what? Yes, twice of angle ABC. Okay, my dear friends, I hope you get this point. So now if this is theta, then we can say it is what? It is 2 theta. It is what? Yes, it is 2 theta. Okay, so now my dear friends, let's see the proof of this theorem. Okay, so my dear friends, we know that according to theorem number 1, we can say that this x is equals to this angle. Okay, so we can say angle ACD is equals to angle ABC is equals to what? X. Okay, this is what? This is by theorem 1. Okay, I hope you get this point. And now the triangle ABC is on the circumference of the triangle. Okay, is on the circumference of the triangle with the center O, which is a center of a circle. Okay, now from the center O we have to join OA and OC. We have to join what? OA and OC to form a triangle AOC. To form a triangle AOC. Okay, my dear friend, I hope you get this point. So now my dear friends, we have x and this angle, let's suppose we are taking y and this angle is what? X, because we are drawing OE to bisect the triangle OAC into equal parts. So that's why angle Z is equals to this. So these are the two equal angle. Okay, my dear friends, I hope you understand this thing. So now my dear friends, we know that this is a tangent DC and OC is what? Is the radius of the circle. So this will become a perpendicular angle. So angle OCD is what? Angle x plus y, which is equals to 90 degree. Okay, my dear friend. So now here we can write as x plus y is equals to what? 90 degree. This is our first equation, because this is a tangent. CD is what? Tangent. And OC is what? OC is a radius which is perpendicular to this tangent. Okay, and y plus x is a angle OCD, which is equals to 90 degree. Okay, my dear friends, I hope you get this point. Now we know that this angle Z, okay, OAC, okay, OAC is an angle in which OE is bisect this angle. So we get angle, we have angle AOE is equals to angle COE is equals to what? Z. Okay, my dear friends, I hope you get this point. So now in triangle, okay, COE, here we can see that angle Z plus angle Y plus this angle, which is 90 degree, okay, is equals to what? 180 degree by angle sum property. So we can write here as angle Z plus angle Y plus 90 degree, which is equals to 180 degree. Okay, I hope you get this point. So now this will become Z plus Y is equals to 180 minus 90. We get 90 degree. So this is second equation. This is what? Second equation. Okay, my dear friends. So now, my dear friends, we have two equations. If we compare this equation, we get x plus y is equals to z plus y. And from this, y will be cancelled. We get x is equals to z. X is equals to what? Z. I hope, my dear friends, you get this point. So now we can write it as, we know that angle ABC is equals to angle ACD, which is equals to x. Okay, and therefore we can say angle AOC is equals to twice of z. This angle is angle AOC is z plus z, means twice of z. So we can write it as angle AOC is equals to twice of x, because we can write x in place of z, because z is equals to x. I hope, my dear friends, you get this point. So now angle AOC is equals to twice of angle ABC, because x is what? Angle ABC. So from this, okay, so my dear friends, this is the proof of theorem second. Hence proof. I hope, my dear friends, you understand these things. Okay, so now let's move to the next theorem. Theorem number third, angle in the same segment theorem. Okay, so this theorem states that angle which are in the same segment are equal. Angle which are in the same segment are equal, that is, angles subtended or made by the same arc at the circumference are equal. So this theorem is saying that. So now, my dear friends, according to this statement, we can say that angle ABC is equals to angle ADC is equals to angle ADC. Okay, my dear friends. So now we have to prove this. So for this, we have to join OA and OC. Okay, and let angle AOC is equals to x. So now, my dear friends, by the theorem number second, we can write it as x is equals to twice of angle ABC, okay, by theorem 1. Okay, and this is our equation number 1. And we can say also x is equals to twice of angle ADC. Again, this is by theorem number 1, and this is our equation number 2. And if we compare equation 1 and 2, we can write it as angle ABC is equals to angle ADC. Okay, because this 2 and this 2 will be cancelled, so we get A is equals to angle B, and hence proof. So we can say that the angles on the same segments are equal. So my dear friends, these are the three theorems which are very important. Yes, so now my dear friends, let's do some questions. Okay, so the question number 1 is, what is the area of the segment corresponding to the arc subtending at an angle of 60 degree at the center of the circle with radius 6 centimeter? Okay, my dear friends, I hope you get this point. So now, my dear friends, we have theta is equals to 60 degree and radius is equals to 6 centimeter. Okay, so my dear friends, we have to find the area of this green portion. Okay, let's take this point as a P. So now, my dear friends, we have to find the segment A, B, P, A. Okay, so first of all, we have to find the sector. We have to find the area of sector AOBA. Okay, AOBAPA. Okay, let's find the area of sector. So area of sector AOBPA. Okay, this is what? This is the area of blue region and green region. So what is the area? We know that theta upon 360 into pi r square. And what is the value of theta? This is 60. And what is the value of r, which is 6 centimeter, which is square, because there is r square. So now, my dear friends, this 0 and this 0 will be cancelled, and from 6 we can write is, we can cut it 6 times. So we get 1 upon 6 into pi into 6 into 6, and 1 6 will be cancelled. Okay, so my dear friends, we get 6 pi centimeter square. This is the area of sector AOBPA. Okay, my dear friends, I hope you get this point. So now, my dear friends, let's move on. Yes, so now we have to find the area of triangle AOB. We have to find what? Area of triangle AOB. Okay, yes, area of triangle AOB. And we know the area of triangle is what? Area of triangle is r square sine theta by 2 cos theta by 2. Okay, my dear friend. So we know what is r. So the value of r is 6 square, and the sine theta by 2. So sine theta is what? 60, which is divided by 2 into cos 60 by 2 again. So this will give 36 into sine 60 by 2 means sine 30 degree into cos 30 degree. So we get 36 into, this will give 1 upon 2, and this will give root 3 upon 2. Okay, and if we solve it, if we divide this, so we get 18, and if we divide 18 from by 2, we get 9. So we have 9 root 3. So area of triangle AOB is 9 root 3. Okay, my dear friends. So now, my dear friends, we have area of sector and we have area of triangle. So now with the help of this area we can easily find the area of segment ABPA. Okay, so now let's find that. So area of segment ABPA, which is equals to area of sector which is AOBPA minus area of triangle AOB. So now my dear friends, we know that area of sector is what? 6 pi and area of triangle is 9 root 3. So we get 6 pi minus 9 root 3. Okay, so now we get, if we take 3 as a common, we get 2 pi minus 3 root 3 centimeter square. So this is the area of segment what? ABPA. I hope my dear friends you understand these things. Okay, so that's the method to find the area of segment. Okay, now let's move on. So now my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much guys for listening me, and take care and goodbye.